This looks familiar.
Damn, keys.
Your life could be this easy.
Alright. I thought it would be cool to add Wi-Fi controls to my door. What this project allows me to do is to access my door from a variety of different devices, as well as give keys to other people so that they can come in and water my plants. So this is the final version of the project. It's about 90% done at this point. All that's left is for me to 3D print a case for it. What you're looking at here is a proto board with the microcontroller and other wires soldered onto it. And this is the motor that actually controls the door. So currently this is controllable from a smartwatch, an Android app, and the internet, or a website rather. So I'm going to do a quick demo of how this works from my watch. So I just double tap to launch the app, and then my door is currently locked, so I can unlock it and lock it. This green background means that the microcontroller actually received the lock signal and that the message was successful. Now if I unplug this and try to send the signal again, I'll get a red background so that I know that it didn't work. Alright, so next I'm going to cover the actual steps of the project. Alright, so this is the hardware side of my project. It's a bit messy right now because I haven't transferred it to PCB, but regardless I want to go into a quick overview of it. There's not too much to see on the breadboard. This is a Node MCU ESP8266 that is controlled from my server over MQTT. It's powered by this 6-volt 2.5 amp power supply. That powers everything, including the servo and the microcontroller. On the breadboard itself, there's actually just this button, the microcontroller, and this op amp. The button is for a time delay, so once I hit the button after 25 seconds, the servo will automatically lock, useful for when I'm leaving the house, etc. The op amp is just to drive up the PWM signal from this board from 3.3 volts to 5 volts. I'm using this servo, which is pretty heavy duty. It's a Metal Gear servo, so it actually needs the full 5 volt PWM. The way I have it attached to my door is via Velcro. I made this metallic arm from sheet metal. I just cut it with some tin snips and bent it. So this just velcros to my door, which works pretty well as a stabilizer for the servo. I eventually want to 3D print something a little bit better, but for now it works. It's just screwed to the servo with some bolts and nuts. And then I also made this little clamp from sheet metal as well. And that's basically it for the hardware. Alright, so this is the Android side of things. This app is pretty straightforward. It just makes a couple of REST API calls, and the server that it makes the calls to is what actually handles the logic and the communications with the microcontroller. So regular users will mostly stick to this login button and these two lock icons. I'm an admin user, however, so I'm going to create a new user for this video. So after this demo user, we're going to hit create, and the server is going to show us that that was successful. So now demo is a valid login. Next, we're going to actually log in as the demo user. And once this is successful, we're going to get a pop-up that tells us how to use the app. It's pretty straightforward. So once you hit OK, you go back to the home screen and you click the lock buttons to do stuff. So if I click the lock button, it will lock the door, and if I click unlock, it will unlock the door. Now here's some fun lock spam. So next, I will remove the demo user. And now it is no longer a valid login. And that about covers it for the Android side of things. Next up, the server side of things. Alright, and finally the server side of things. What you're looking at is me VNC viewered into my AWS hosted server. Don't mind the black bars, they're just hiding my IP address. So this is probably the most boring thing to demo, but this was the meat of the project. Using Node, this serves up the endpoints for the Android app or any web apps to access. This also communicates with the microcontroller using MQTT. On the screen, there's some information. Basically, what that is a logger. It logs any access attempts on the endpoints. It tells me what login rather was used to access the endpoint, what they queried, what the timestamp, and this is just what's logged in the console. There's also a separate log file, which contains some more detailed debugging information and stuff like that. I'm not going to get into the log file right now because there might be some sensitive information there, but basically I can differentiate between a user login, an admin login, and any operations that are being done. And that about covers it. So what you guys just saw was a little bit less complete than what you saw in the intro. I made the demo as I went, so the intro actually had the more complete version. And that about covers it, so thanks for watching my video, and I'll see you guys next time.